Now let us say we have to construct a Murray machine which takes set of all strings over 0 comma 1, which means sigma equal to 0 comma 1, and produces capital A, which means delta is going to output has to be capital A. If capital A as output, if input is ending with 1 0, which means if the input ends with 1 0, I should produce capital A, or produces capital B as input ends with as output if input ends with 1 1. If the input is ending with 1 1, I have to produce capital B, otherwise it produces C, which means I have to identify between three cases, whether the input is ending with 1 0 or the input is ending with 1 1. Fine. So how we can do it is, we have to directly draw a DFA where a string is going to end with 1 0 or 1 1. So DFA for strings which have to be, we are going to accept set of all strings which are going to end with 1 0 or 1 1. So initially I am going to see 1. See, I am not going to explain the method of how to construct the DFA, that we have already discussed in the previous question. So I am directly going to draw the DFA. So if it is going to end with 1 1, I will be in this state. If it is going to end with 1 0, I will be in this state. Okay. So now let us fill the finite automata. So let us assume that the states are x, y, z, because ABCs have already been taken for delta. Let us say x, y, z and w, right? So if the input is going to end with 1 1, I should print B. So in Z I am going to print output as B, and if the input is going to end with 1 0, I have to print A. Therefore here I am going to print A, right? So let's finish the deterministic finite machine. In capital X, if I see any number of zeros, I should just wait for 1, and this is complete. And capital Y can see 0 or 1, that is complete. Now if I am in state this one W, how did I write this W? After seeing 1 0. If I see one more 1, I should either wait for a 0 or 1. So if I see one more 1, I will either wait for a 0 or 1. Now if I am in 0 0, if I am state W, which means I have seen 1 0, if I see a 0, the entire sequence is spoiled, and again I have to wait for 1 0 or 1 1, which means if I see a 0, I'll come back and again I'll wait for 1 0 or 1 1. So this one is complete. Now in state Z, how do I reach Z? I have reached Z by seeing 1 1. If I see one more 1 or any number of ones, it is still ending with 1 1. Therefore any number of ones is still ending with 1 1. Now again I have reached Z on seeing 1 1, If I see a 0, it is nothing but ending with 1 0. If I see a 0, I'll come here. Why? Because it is ending with 1 0, right? So this is it. If I am in cap W, the output has to be A. If I am in Z, the output has to be B. Otherwise the output has to be C. So in the remaining states, output has to be C. Now you can just give me an example and we shall trace it out. Let us say I have to trace out the example 1 1. The input is 1 1 1, which is ending with 1 1. Therefore the output has to be B. So I'll start with X. Initial state is X, and on seeing 1 I'll go to Y, and on seeing 1 in Y I'll go to Z, and on seeing 1 in Z I'll still go to Z only. So the outputs are going to be C, C, B, B. So what we need not care about all these things, we are going to care about the last output, which means if the input is going to end with 1 1, definitely we are going to see B in the ending. Let us say 1 1 0 is the input, then initially I will be in state X. On seeing a 1, I will go to state Y, and on seeing a 0 in Y, I will go to state W, and on seeing a 0 in W, I will be going to one second. So let us say input is 1 1 0, on X on seeing 1 is going to Y, Y on seeing 1 is going to Z, Z on seeing 0 is going to W. Now look at the outputs. What is the output associated with X? C, Y, C, Z, B, and W, A. Therefore, final output is A. This is what matters, not all this, right? So if the input is going to end with 1 0, we are going to see A. If the input is going to end with 1 1, we are going to see B. Don't care about the other outputs. Okay, so this is the solution for the given problem.